Good morning. I am Navina Priyadarshini, Professor of AC Department, Rohini College of Engineering and Technology. In today's class, we shall discuss about the analog transmission systems in satellite communication. So in satellite communication, for the signal transmission, it may uses two types of signals. So it may be an analog signal or it may be a digital signal. So the two methods are used for transmission of data or telephony or the video signals. So the two different techniques are employed for analog transmission via satellites. One is the multiple channel per carrier technique, which is denoted as MCPC, and another one is the single channel per carrier, it is denoted as SCPC. So in multiple channel per carrier method, the carriers are amplitude modulated by groups of multiplexed voice channels from terrestrial systems. And in the second case, that is for SCPC, the single channel is assigned for its own individual carrier. So it's of two types, analog SCPC and digital SCPC. So here an analog SCPC system which uses the frequency modulation. So next is the AM single band suppressed carrier methods, which uses the AM modulation schemes. So therefore, for analog techniques in commercial satellite communication system for transmission of signals, it may uses the amplitude modulation, frequency division multiplexing, as well as frequency modulation. So first is the amplitude modulation. So amplitude modulation, we can say that it's the process by which amplitude of the carrier signal is varied in accordance with the amplitude of the message signal, where the frequency and phase of the carrier signal remains constant. So here consider a modulator which has two inputs. One is the message signal, another one is the carrier signal. So the message signal will be a low frequency signal and carrier will be a high frequency signal. These two signals are given as the input of the modulator. So both are here we are consider both as the cosine signal, and next at the end of the modulator, at the output of the modulator, the two signals are get mixed up and produces the modulated signal. So the modulated signal will be a high frequency signal than the message signal. So when we analyze the modulated waveform, the amplitude of the modulated waveform which traces that means the envelope of the amplitude modulated waveform traces the message signal. So we can say that in the carrier signal, the message signal lies in the amplitude of the carrier signal. And when we are representing this signals in frequency domain, it has a number of two sidebands will be there. They are denoted as upper sideband as well as lower sideband. So when amplitude modulated signal, which consists of three components, one is the carrier signal, another one is the upper sideband, another one is the lower sideband. The upper sideband as well as lower sidebands, which carries the same information on both the frequencies. So next is a modulation index. So modulation index is an important parameter which defines the depth of the modulation. Here it is of three types, three categories are there. One is over modulation, critical modulation, and under modulation. So you can say that modulation index, it is the ratio of amplitude of the message signal to the amplitude of the carrier signal. So if the modulation index is less than 1, it is represented as under modulation, and if the modulation index value is equal to 1, it is represented as critical modulation, and if the modulation index is greater than 1, it is defined as over modulation. So in case of under modulation as well as critical modulation, if we choose the modulation index value, that is Vm value is less than or equal to Vc, then that is the amplitude of the message signal is less than or equal to the amplitude of the carrier signal, the signal can be perfectly modulated. And if the modulation index value which exceeds the 1, then the envelope of the upper and the lower signals will be get overlapped. So in that case, it cannot be possible to recover the message signal at the receiving end. In AM, there are subcarriers are there. So here we are while transmitting the carrier as well as the sidebands, it requires more consumes a large amount of power. So to reduce the power consumption, we can go for suppressed carrier schemes. The first one is amplitude modulated double sideband suppressed carrier. So in this method, the signals carries only the sidebands and the carrier signal is get suppressed. So double sideband suppressed carrier. So both the sidebands are transmitted here and the carrier is suppressed. So next is the SSBSE. In SSBSE, the carrier signal as well as the one of the sideband is get suppressed and only one sideband is transmitted. Because of that, the power consumption is get highly reduced when compared with general transmission of AM signal. So the power relationship is the total power of the signal is given as P, which is the sideband power. So at the receiver, the noise power is given as N, which is equal to N naught into B. So B is the bandwidth of the AM signal, which is N naught. N naught is the power spectral. N is the noise power. So whose power is N naught by 2, and bandwidth B is 2 FM. So that the total noise power is N naught into FM, and the output signal power is calculated as SB, which is equal to K into S. So the signal noise ratio is the ratio of signal power to the noise power. While substituting all these values, we will get signal noise ratio as S by N naught into FM. So when compared with conventional AM, SSBSC techniques requires less power and it is an efficient modulation scheme. Thank you.